From Photonics Media, this is All Things Photonics, a podcast shedding light on industry-shaping advancements in lasers, optics, imaging, metrology, and sensing. Each episode, our hosts speak with luminaries, rising stars, and market leaders about the trends shaping the current and future landscape of photonics. From space and deep-sea exploration to precision timekeeping and advanced manufacturing, this is the podcast for progress on All Things Photonics. This season of All Things Photonics is brought to you by Polyscience and Ayar Labs.
Today's episode is brought to you by Polyscience. For over 60 years, the Polyscience line of award-winning temperature control equipment has been helping the photonics industry reach its goals safely and efficiently. Our products are made in America and delivered globally. Please visit polyscience.com to learn how we can help you. Changing the world of chillers is more than a tagline. It's a part of our history. Today's episode is also brought to you by Ayar Labs. Ayar Labs believes in the positive impact of photonics and hopes today's discussion inspires you. We're a vertically integrated photonics designer and manufacturer dedicated to making your ideas successful. To join our team or to learn more about our stocked offering or custom solutions, visit thorlabs.com.
If ever you were asked to deliver a 30-second rundown on the optical technology of your choice, you'd be a braver soul than those on this podcast to select optical interconnects. The nuances of in-package optical I/O and co-package optics, for example, are not easily articulated in a half minute. And that's only one example of a critical distinction that serves to peel back the layers on a technology that, like so many we discuss on this podcast, is perhaps better conveyed by its applications than its definition. Silicon Valley-based Ayar Labs is flush in the middle of this technology space. And today on All Things Photonics, Terry Thorn, the company's Vice President of Commercial Operations, joins me for a multifaceted conversation. Ayar's solutions and commercial offerings, namely its Supernova light source and Terrify optical I/O chiplet, support the fact the company has been called many things over the past 18 months. Optical networking company, optical interconnect company, and optical solutions provider are just some of the labels applied to the company. Each is, as we've come to learn, an appropriate classification. Perhaps the most critical distinguisher with Ayar is its application target. The company is committed to solving AI system bottlenecks, and its optical interconnect gains are a vehicle down that road, as the road itself widens and extends with the possibilities offered by AI. But does that mean Ayar's own roadmap is continuously evolving? An answer to that question, and many others, is up next with Terry Thorn.
Today's episode is brought to you by Avantes. Unlock the power of light with Avantes. For over 30 years, we've delivered precision fiber optic spectroscopy, trusted for custom integration and reliable data. Discover how to empower your application, industrial, scientific, or beyond. Visit avantes.com and experience spectroscopy solutions that innovate. Today's episode is also brought to you by LightPath Technologies. From concept through prototyping, volume production, and global distribution, LightPath has the optical knowledge and manufacturing expertise to be your optics partner every step of the way. Visit lightpath.com to learn more.
Ayar Labs' Terry Thorn is with us today on the All Things Photonics podcast, and I want to start, as we often do, by giving our guest an opportunity to introduce himself and the company on which he speaks. And obviously, Ayar Labs has been described as a great many things over the last 12 months and even longer. Optical interconnect company, optical connectivity company, optical networking firm, and all of those labels, I think, are somewhat apt. But I do have you here, Terry, so why don't we begin by having you introduce Ayar Labs?
Hey, thanks for having me. Ayar Labs is really about transforming AI infrastructure by accelerating data movement. So we are we make an optical internet chiplet, interconnect chiplet with a remote light source, but it's really around data traffic and how do we transform AI infrastructure.
Okay, and that's helpful. I think we should also probably now ask you another question that will serve as a sort of table-setting item, but I think it's a good place to start. What's the base level understanding that our listeners should have as we talk about co-package optics versus in-package optical I/O?
Yeah, I think that's actually a really good place to start. So obviously both technologies involve moving data with light, right? They're both optics technologies. Traditionally, when you think about CPO and co-package optics, it's really around having a replacement for pluggable optics, as an example, and really thinking about the scale-out fabric within a data center. So it's kind of geared toward large Ethernet network switches with bandwidth density and energy cost and latency that's better than what you can get through, say, a pluggable optics solution. So that's co-packaged optics. What we do with in-package optical I/O is it is a chiplet-based optics solution that is packaged with the compute chip. So it's in the same multi-chip package, and really it's targeting memory semantic compute fabrics. So if you want to think about the term scale-up fabrics, that's what we are targeting, whereas traditional CPO is more about the scale-out fabric. So those are the baseline definitions. When you look at things that are different as far as how the figures of merit go, energy efficiency, shoreline bandwidth density on the chip, on the host chip, latency, those are all areas where in-package optical I/O has advantages over traditional CPO modules.
Okay, so this is all very helpful, and I call it table setting. This is not, I would say, basic information, but for the purposes of this conversation, I think it is. And within the framework of what we've discussed here, I think it's fair to say that Ayar Labs' sort of macro scale undertaking is to solve AI system bottlenecks. And that's a dynamic quest or a dynamic undertaking, just given the nature of the fact that these are always changing. But for now, how do we see AI and the nature of these bottlenecks?
Yeah, so, when you start talking about AI infrastructure, it gets really exciting in just the technology advancement. So if you think back even to, say, Q4 of 2022, which is about 2 years ago, you got kind of the first instantiation of ChatGPT coming out into the marketplace. And then ever since then, it's just this fast pace of improvements and releases and other AI models coming to market. And with all of those, what we see is that there's an increase in parameter sizing of the model and just the complexity of the model. So what quickly happened was that the model size and complexity got too large to fit into, let's say, the memory that's associated with a single GPU. And so they ended up dividing, from an architectural standpoint, you end up dividing the workload into smaller parts, and then you place that across many GPUs that may be in a single sled of a compute server or maybe across the compute server. And all of those GPUs are then connected and act generally as one to work on the AI model. That's where connectivity becomes a challenge, because you're moving all of these parameters and all this data around with traditional electrical copper-based interconnects. And so what you find is that in those models, those compute chips end up actually spending significant time either transferring data and or waiting to data to compute with. So that's where the bottleneck happens, is you get all this data going back and forth that gets slowed down to the point that the compute chips aren't constantly computing. They're actually waiting idle to address the data that's coming in when it comes in. So what we do, as I mentioned earlier, is we release kind of the future of AI by giving a much bigger bandwidth, lower latency, and actually lower energy solution into that chip-to-chip connectivity within those AI systems. Now, with all that being said, it is a new area, so to speak, or a new marketplace. And so you start to think about, well, how do we measure the productivity within those AI systems? And what we recently have been talking about, and we've shown a simulation model that we've created that gets into a token-based figures of merit. So tokens being one thing that gets produced with inference models that consumers use on an AI model. On the inference side, you measure data in what's referred to as tokens. So with our simulation, what you see is that token generation, or how quickly you create tokens per second from your AI model, Optical I/O releases a whole nother level of capability in token production. So your figures of merit start to show interactivity and profitability increasing as you go from copper interconnects into optical interconnects, chip-to-chip interconnects. So, I've said quite a bit there, but when you think about the macro scale undertaking of AI system bottlenecks, you have to think about both what the challenges are within the problems, and those challenges are this ever-increasing amount of parameters and complexity of the models, and then how do you measure the improvement that you're getting with introducing new technology like ours. And that comes through in how you look at token production and profitability of how many tokens you're producing, and how you're using the AI model from a customer interactivity standpoint. So that's how we look at the undertaking itself.
So there are a couple things here, right? And they're particularly interesting because you have sort of the nascence of the technology that Ayar Labs is introducing, but you also have the nascence of the technology space more broadly. And then anytime you factor in AI, there's this inherent sort of newness there. Strictly speaking, from a sort of through a photonics lens, how do you view the opportunity to harness AI or to use it in a strategic and meaningful way to benefit the solutions that you're ultimately targeting?
I think what we get to with the complexity of the AI models is what I talked about with the figures of merit. And we talk about tokenization and the economics of tokenization and what you get. And so when we look at that and we've run the simulations around that idea, the scale-up fabric being converted from the electrical copper-based traditional stuff to the optical interconnect that we offer really starts to get measurable and quantifiable in those AI models. And so I think the way we think about it is we set a baseline of today of what we can do with if we took state-of-the-art technology today, copper and electrical interconnects, and we applied our technology, and then what would it look like in the future? So when you look at it today, if you take state-of-the-art and consider, ChatGPT-4 as state-of-the-art, deploying the simulation that we have with our technology, you start to get profitability that's about 6 times better, and you get interactivity, which is how the user engages with the model, that's about 4 times better. If you look out in time, those models are continuing to grow. As we talked about, it's a very dynamic marketplace. If you think about what the models could look like in, say, 2027 timeframe, you get into a much better profitability position using optical interconnects between those chips, roughly 20 times better. And you still maintain that 4x better interactivity using our technology. So when you look at the landscape and the industry and how quickly it's changing and what's going on, it's really important. The way we look at it, it's really important to kind of baseline what value do you bring to the challenge today? And over time, how do you improve your value that you're bringing to the challenge? And so that's the way we look at it.
Ayar Labs authored a piece in, I guess it was earlier this summer. It was in August, Optics and Photonics News. And Terry, you as the author remarked that some of the momentum around electrical and copper, it's hard to bypass, right? That's it's now sort of a legacy technology, but it's a very effective one. It's proven sort of as the baseline for much of this newer technology. How does having a mature, established template in many ways spur momentum in what Ayar Labs is working on now, where you're sort of really kickstarting a paradigm shift?
Yeah, I think anytime you're trying to introduce a shift in technology, especially in a very well-established market, and people have designed and used copper to move data really for decades with computing devices. What we see that is, so you can prove, I would say you can show that optical interconnects do it with less energy and with greater bandwidth, and you can show that performance in metrics. But what you really need in the marketplace is a pull through of that need. And thankfully, that's what we see with the AI complexity of AI models. So in the past couple of years, when we've actually seen these AI models in usage in the marketplace, And we've started to look at, parameter count and complexity of the models. And as I talked about earlier, how those models have to be spread across multiple compute chips. That really pulls through the need for embracing a new approach to the interconnect between those chips. So there is a lot of momentum, obviously, around how things have always been done. I think the impetus now is recognition that will not work if we want to keep getting the value of AI systems going forward. You have to make a change. And so that pulls through the introduction of optics into that chip-to-chip connectivity.
Just on this theme of moving from perhaps established application area or technology to something new and ultimately different, I want to understand Ayar's Terrify optical I/O chiplet. But I think I want to frame this question as I speak here out loud in terms of the applications, right? And you have things like AI datacom, cloud computing. These are all undoubtedly new, right? But you're also supporting things for pursuits in the defense sector, and these are, as far as optics and photonics are concerned, relatively established application areas. How do you view that contrast? Is there benefit to having sort of this template to work from?
Yeah, so the way we see it, if you think about the long view over the next, say, 10 years, anywhere that you've got a data movement challenge that benefits from lower latency, higher bandwidth, and lower energy to move those bits of data, you have a target application for implementing chip-to-chip optical solutions like ours. So anywhere you have that challenge, there's an opportunity to implement the chip-to-chip optical solution. Now, the other thing, and that's true with obviously with data centers and servers that we talk a lot about, but the other thing is, especially in kind of the defense and other industries, is you also start to look at things like size, weight, and power trade-offs. And those become the real critical kind of figures of merit. And if you want to think about it from whether you're thinking about a ship and the radar that's on a ship, or you want to think about it with an airplane and what's in an airplane, if you're running, and I mentioned radar because that's one of the pieces we worked on with Lockheed, is the idea that if you're running radar systems in an airplane and you're using copper wires and copper to run that data versus using fiber, which is much lighter and uses much less power, you actually get benefits in not only how the radar systems can be architected, but also the weight trade-offs and improvements of power usage inside that envelope of an airplane or maybe a ship. And so there's inherent benefits in those types of applications that may not actually see the same benefit in a data center, or may not be as important in a data center when you think about, for instance, weight. So we see applications in defense industry. We also have worked with people like Ericsson, and we see benefits in how they design things like cellular towers and how much AI you can run on the edge with some of those engines in the cellular towers that may be at the top of the tower, as opposed to bringing it down to a base station or local station. So there's a lot of applications of the technology over time. And again, it comes back to the basic premise of, if you're moving a lot of data and you can benefit from improved energy efficiency, improved bandwidth, and improved latency, then there's an application option with our solution.
How do some of these application ideas get presented? I'd love to be able to sit in on a meeting with Ayar Labs and an Ericsson, say, because the applications I suspect are, you have an application in mind and then it sort of builds on itself. Well, if we can do this, we got to be able to do that. But when you're working with a new technology, maybe not. I mean, how do some of the applications come to mind? Is this just sort of, well, if we build it and then we iterate it, we've reached a new level? Is there some idealism there? I'm just curious. Take us inside, if you will, a meeting at a very high level.
No, it's a great question. It's one of the reasons that I joined the company. Was I spent my career over a couple of decades of my career with working with Intel and working with a bunch of data center customers, and I think one of the things at Ayar Labs that's really attractive was, first of all, we are showing our solution in live demonstrations. So at various events, and we do it in private, and we show various things publicly and other things privately. But when you start to show that the technology is live, there's silicon, it's working, we run it for days on end at these events, then you start having people come out of areas that you haven't thought about before. That may be the telco industry, for instance. And they'll say, well, my challenge is, I'm moving data from here to here, and if I could get it there faster, I could operate with it differently. So it really starts with defining what is the challenge, the data movement problem that they are facing. And then you quickly get into, this is how we might be able to apply what we do. It gets super exciting when people come up and start to engage you on a problem area that you never actually maybe even thought about, because you don't understand. Coming out of like I said, my history has been in kind of compute and the data center side. I don't, inherently understand how cell towers work, but I'm learning how cell towers work because they do face, or radar systems for that matter, when you start talking about dynamic range of a radar system and what you can see on the horizon, both in depth and in width, and you're able to do that in an improved way if you have more data at the edge faster, and latency is really key. You start to learn about different applications that could benefit from our technology. So that's how it really starts with the challenge they're facing, clearly defining it in their figures of merit. And then the application side of it, becomes a bit more, I would say, mechanical in how we apply the technology. But it's really solving their problems that is the exciting part of the definition stage.
We sit here now, and it is the calendar has just turned from September to October, and that's ECOC time, right? That is the show of the season, so to speak. When a company like Ayar Labs goes to a show like that, I mean, it is a very targeted audience, but are you using those as, I hate to use the phrase selling show because that sort of connotes something different, but are those the forums where these idea bouncing sessions are happening, where you're sort of, learning and sharing and ultimately getting towards a solution?
Yeah, I think, whether it's ECOC or supercomputing, which is coming up in November, those are kind of big shows for us as we wrap up each year. We do a couple things at those shows, but yes, we come out with our partners and do some work. We were in at ECOC. We did some things with Sivers, which is one of our partners that we collaborate with on our light source. We did some work with Corning. We were we're doing some glass waveguide work with Corning that was showcased at ECOC. And so we do use those events to bring out, to both kind of bring out new technology ideas, as well as to collaborate with our partners on what we're offering together. Because, our success is dependent on an ecosystem of partners that are, that need to be successful too, right? We don't do it alone. And when we look at supercomputing that's coming up in November, we've got some ideas there, some things that will bring new that we haven't shown before. So those shows do help us engage with customers and also just thought leaders in the industry about what we're doing and where we're heading. So those are cornerstone for us as we go through each year. There's 3 or 4 of these types of shows that we really benefit from participating in.
We mentioned the Terrify optical I/O chiplet earlier. I want to talk now about Supernova Light Source, and this has been an iterative design process and ultimately unveiling. Debuted it last year, supported 8 wavelengths, doubled that wavelength value. You're driving 256 optical carriers, right? So this is an improvement to an existing solution. I want to ask you a couple questions, but first just about the design, because you're not necessarily conceptualizing, but you're building upon an existing design. And what's the challenge there? Because I have to imagine it's a unique set of challenges when you're taking something and making it better, or trying to.
Yeah, so we've been like you said, we've had our laser light source out in public demonstrations for a few years now. And our first generation was a 8 wavelength oriented light source. It had 8 ports and 8 wavelengths per port. So if you want to think about a port as a fiber coming out of a laser module, and that paired very well with the Terrify optical chiplet generation we had at the time. We've now showcased both at OFC here in March, as well as at ECOC. We've showcased different ways to do a more compact light source module and to have 16 wavelengths per port on that module. And that does give us, the ability to do, to enable greater capabilities within our Terrify optical chiplet roadmap. But, stepping back to your question, we build off of a DFB array. We've been public about our partnerships on the sourcing of that. And the flexibility that we have with how that is set up really gives us the levers to support kind of the 10 plus year roadmap of our technology growth. Because there's certainly things you can do with, and we've shown that you can do with wavelengths per fiber or wavelengths per port. There's also things you can do with modulation of the light source and how you're modulating it that can get you to increased bandwidth over time. So, thankfully we've got great partners we're working with, and that supports the roadmap of the chiplet for the next 10 plus years of growth. It's kind of a natural progression over time.
Yeah, natural progression. That's an interesting phrase feeding into this next question. The nature of the roadmap, right? And you're working in a new technology. There are going to be some surprises, some good ones, some setbacks. Is the roadmap constantly changing? Is the roadmap set? Are there new sort of, details that come into the roadmap? How's that work for a company doing what Ayar Labs is doing, where the sort of the dynamic nature of systems design is, dynamic?
Yeah. No, it's a great question. I think in a startup, it's critical to be responsive to your customers' requests and responsive to market dynamics. I will say, I joined the company in 2021. It's about 3.5 years ago. The core technology of our roadmap that we had when I joined and what we have now has stayed consistent. Meaning micro ring resonators are at the core of our chiplet technology, and how we apply those and what we were saying on our roadmap 3 or 4 years ago when I joined is what we're delivering now and will continue to deliver over the next 10 plus years. But how you package it and or the application of it, those things are, you can edit those as you go based on what a customer needs or what the marketplace needs. And we have done some of those changes. When we first, a good example is when over the past couple of years, we've heard from our marketplace that having on the fiber attached side, let's say of the chiplet, having a way to detach the fiber and having a detachable connector for the fiber is important for multiple reasons. And so, we took that input and we've been pursuing with partners, how do we deliver that solution? But that's a fiber connector portion of the technology, not the core technology of the microring architecture and what we deliver. So it's a little bit of, we definitely change the roadmap as we need to meet the customer and the marketplace needs, but the core technology of the roadmap and how we scale that and leverage that over time has stayed consistent.
I want to end with this, and you're on the commercial side, and that may influence your answer to this question. But I'm curious how you chart progress, how you gauge progress in industry. Is it increasing values of a certain parameter? Is it commercial success? Is it sort of the success of the industry sector more broadly, the success of this sort of niche within the industry sector? And the reason I ask is you're working with a new technology, and I don't think this is necessarily something that's defined yet. Something with more mature, you may sort of have a clear understanding of how progress is measured. I don't know if that's the case here, though.
Well, I think the way that we look at it, the journey that we're on with Ayar Labs and our technology is, again, I'll just talk about the time at which I've been at the company, and the company's been around for 9+ years. I've been here for, say, 3.5 of those. But, even the short time that I've been here, we went from questions around, does the base technology actually deliver to the promises that we had prescribed for as we started the company? We've proven that, we've shown it publicly, we continue to show it publicly, as well as improvements on the technology as far as the cadence of our roadmap. So I feel like we have success measurement, we have progressed beyond the point of being considered just an R&D topic. We are now spending our time with our customers and our ecosystem partners on the technology works. How do you build millions of them a month? How do you get to that level of high volume manufacturing? And those challenges are real challenges too, right? It's not just a matter of if you get the technology working, all of a sudden you've completed everything. You can check the box and go home. It doesn't work like that. The technology has to work, and then you have to make sure that you have manufacturable solutions in high volume for that technology. So that's where we spend a lot of our time today, and how we judge success internally, as are we progressing to that path? And of course our customers help us put up the scorecard of what's needed for them, so we know if we're progressing down the path or not. So I think the journey of the company, and maybe of all startups, is first you start with a great idea. Then you show that the idea actually has merit. And in silicon, anyways, you show that the silicon actually works, right? You can make the silicon and it does what you say it was supposed to do. Then you have to cross the thought process of, okay, I can make thousands of these. I can make 10,000 of these, which, is the type of work that we've been doing, but that's different than making, call it 1 million a month, right? That's the challenge now. So that's part of how we look at kind of the ever-changing metrics of what success means with our company. At different phases, it means different things. At the phase we're in right now, and I think the phase we'll be in as we go to commercialization in the 26 to 28 timeframe, is getting that high volume manufacturing put in place.
Terry Thorn from Ayar Labs, from the C-suite level, kind enough to join us on the All Things Photonics podcast. Terry, I appreciate your time. Best of luck moving forward. Have a great fall, and we'll talk again soon.
Thank you very much.
With that, we conclude another episode of All Things Photonics. Thank you to our sponsors, to the technical staff behind the scenes, and to continued support from the Photonics Media editorial team. As always, questions, comments, thoughts, and ideas are welcome. Let us know how we're doing via email at allthings@photonics.com. All Things Photonics is available on all major platforms and on our website, photonics.com.